Welcome to the multivariable calculus section. Today we will be discussing the cross product. Now the cross product, or the vector product, takes two linearly independent vectors and produces a normal vector. Today we will be looking at the two vectors A and B. So here we have A cross B. When we expand this, we get the 3x3 matrices comprised of our three components of any basic vector. We have our I and J and K component, followed by A1, A2, A3, as well as B1, B2, and B3. What's important to know here is that order does matter. When we have A cross B, we will have our A components followed by our B components. If we had B cross A, we would have our B components followed by our A components. So, since it's been a while since we've utilized matrices, and because cross products are such an important component of multivariable calculus, I'm going to show you how to solve a 3x3 matrices step by step. So let's get three of these just to get a better understanding. What's going on here is, if we remember our basic formula of solving a 3x3 matrices, we have AD minus BC times our first component minus AD minus BC times our second component plus AD minus BC times our third component. This will give us the answer to our 3x3 matrices. So what's important to understand here is that we are going to utilize each component per expansion, and this is just an easier way to solve it. This will allow us to visualize what we are actually doing. So what is an AD? What is a BC? Well, that is actually not a variable. It is an order. So every time we do this, we have an A, a B, a C, and a D. And we can do this for every single expansion. And this will really help you solve matrices if you forgot how to do it. And if you believe that you are not as strong with matrices, I recommend doing this process. So here for our first form, our first component of I, we are going to do A times D minus B times C. And it is important that you do this exact way. You have to do AD minus BC, otherwise you will not get the same answer that you are supposed to get. And so we have A2B3 minus A3B2 times our first component, subtracted by, and we can do this for our second one, A1B3 minus A3B1 times our second component, which is J, plus our third, which is going to be A1B2 minus A2B1 and our third component. Boom. And that is the cross product, or the solving of any 3x3 matrices. So recall the definition of a cross product, a procedure that takes two linearly independent vectors and produces a normal vector. So when we take the cross product of two non-linearly independent vectors, let's see what happens. So here we have a graph of two vectors that are on the same line, which means they are linearly dependent or non-linearly independent. So we'll say this vector is equal to 0, 1, 1, and this vector is equal to 0, negative 1, negative 1, just to get a general understanding. So what we're going to do here is we're going to do A cross B. And that is equal to I, J, K, and then we know that our A1, A2, and A3, and this is B1, B2, and B3. And we're going to write all three because we're going to get good practice with doing cross product. 0, negative 1, boom. I, J, K, 0, 1, 0, 1, 0, negative 1, negative 1. Okay, perfect. So we're going to do our crosses, boom. Second component, second column. Third component, third column, boom. Now we have our A, B, C, D, A, B, C, D, A, B, C, D. We're setting ourselves up for success here, guys. We should always get the right answer if we set it up correctly, because we set it up correctly. So here we have AD minus BC, so we're going to do 1 times negative 1 minus negative 1 times our first component, subtracted by 0 times negative 1 minus 1 times 0 times our second component, plus, let's do 0 times negative 1 minus 1 times 0 times our third component. Sorry, that's a little squished. But what's truly going on here is we have negative 1 minus negative 1, which is going to give us 0 times I, minus 0 minus 0, so that's going to be 0j, and then plus we have 0 times negative 1, 0 minus 1 times 0, 0, which is going to give us 0k. So when we have two linearly dependent or two non-linearly independent lines or vectors, we get a 0 for our cross product. And that's really because when we have two non-independent vectors, what's actually happening is we don't have a normal vector. We can't draw a vector that is normal to both because they're on the same line. So let's try a problem now. Oops. Okay, so we have our A vector and our B vector, and what we want to do here is we want to do A cross B. So A cross B is going to look something like this. Boom. And we're going to draw out all three because we are practicing, setting ourselves up for success. 3, 7, 4, 1, 2, 5. Boom. Let's do this relatively quickly. 3, 7, 4, 1, 2, 5. Boom. Boom. I, J, K. 3, 7, 4, 1, 2, 5. Boom. And let's do our highlights. First component, first column. Second component, second column. Third component, third column. A, B, C, D. A, B, C, D. A, B, C, D. Oops. Okay. Boom, boom. Boom, boom. Boom, boom. And we should have it here. So we'll do 7 times 5 minus 4 times 2 multiplied by our first component minus 3 times 5 minus 4 times 1 multiplied by a second component plus 3 times 2 minus 7 times 1 multiplied by a third component. Okay, so now we have 35 minus 8 times I minus 15 minus 4 times j plus 6 minus 7 times k. So we get 27i minus 11j minus 1k. And that is our cross product for the two vectors. If you want to do more problems or you need more help and assistance with cross products, we have examples on the website and I recommend those. Thank you so much.